Hi everyone. Let's say I'm an environmental consultant hired to keep track on the environmental impact of a big electricity company. Since my contract is only for a predefined time, I want to leave a few tools for the engineers on site to keep track of the emission of two dangerous pollutants, the nitrogen oxide, also known as NOx, and the sulfur oxide, SOx. The first tool I would like to leave would give the possibility to the engineers to follow the evolution of the emission over a specific period of time chosen by the user from a drop-down list. The report would also be created in order to monitor all the different units that generate such emission. And of course, to make this report user-friendly, all of these options would be picked up automatically when selected, just as you can see right now. In this video, I will show you how to create such a report from scratch. First step when building a report is to identify the elements or units that you want to study. In order to do so, we will use the root path functionality of DataLink on our PySystem data. Let's start by opening a search window from the DataLink tab. In it, let's browse through our hierarchy in order to find our generation level that should be under the power company section. Since we want to monitor all units that are generating NOx, let's write NOx in the search field and press search. It should then return all NOx attributes found in this section of our database. By selecting all of the results and changing the root path length to maximum, you will obtain the root path of all different units that are currently generating NOx. Now, let's select the drop-down list options, since that's what we want to create and that's what we'll be using in our report. Now that we have our root path, we can move the NOx attribute to the right section of our report and also enter the SOx attributes since we are also going to monitor this one. Since they both use the same root path, we don't need to set up the complete path for the SOx attribute. Pretty convenient. The next step would be to create the drop-down list to give the user the possibility to change the start time and end time of the report based on some predefined values. There's three things that we'll need to create in order to make this work. Those would be, first of all, the end time drop-down list, then the time range drop-down list, and finally the start time value. To create the end time drop-down list, I need to set up the different options the user will have access to. In this case, let's just put the star as for now, T as for today, and Y as for yesterday. To create the actual list, select the cell in which you want it to appear, and then browse into the Data tab to select the Data Validation. It will prompt you a window that will contain the different parameters to create a drop-down list. All you need to do is simply select list from the allow field, and then into the source, select the source for the list. In our case, that would be the cells containing the now value, the today value, and the yesterday pi time values. The same kind of list can be then made for the time range of the report. Let's set up the source for the drop-down list with the following options. Let's set 1 hour, 4 hours, 8 hours, 1 day, 7 day, and 1 month. All of this in PyTime. Once this is set up, let's create the drop-down list for the time range. Now that our drop-down lists are created, we need to set up the start time of the report. It will be composed of a mix of the end time and the time range. To create a more user-friendly report, let's use the concatenate function from Excel. this function will simply join the different information given in the report to create our start time. Since the pi time is usually created out of a reference time with an offset, let's build the concatenate function with the following parameters. First of all, select a cell, then write equal concatenate, and select the end time. Then we can add the minus sign in between double quotes, and then add the time range. Now that this is done, we have the start time of our report, which will be useful for the future DataLink function we'll be using. Now we get to the core of the report, the actual data. In order to get all data from the pi system over a defined period of time, I will use the compress data function. This function returns every single values that have been archived in our pi system over a specific period of time. If we start with the NOx, the first thing I would need to do is simply select the compress data function from the pi DataLink tab. By clicking on it, a panel on the right side of the screen will appear with different parameters we need to input. First thing we can choose is the root path. We've already defined a drop-down list of the root path representing the units we want to obtain data for. So, well, let's simply link this field to the right cell. Now the data item. The data item represents the attribute we're interested in. In our case, it's the NOx. The start time is defined by the concatenate function we've done earlier, and the end time by the report end time cell. We can select the interpolated boundary type and check the show timestamp and iCount checkboxes. Once this is done, take a look at the output cell, and since we've selected the show timestamp option, the value will be pushed one column to the right, so let's just keep that in mind. If you press on OK, there it goes, you have your values. The result of a DataLink function is returned in an array format. Because of that, if, as an example, I change the time range for a longer value, well, let's say 7 days, I will get the following message, resize to show all value. This is simply because the array that I've created at first cannot be modified. If you try to change one single cell from the array, it will prompt you an error, and the only way to get out of this error is by pressing the escape key. If you want to resize your array, you can simply right-click anywhere on it and select a recalculate resize function. Once this is done, you will be able to see all the values for your units for the new time range you've set up. The same thing works the other way around. If I reduce the time range, let's say to 1 day this time, I will not be able to modify the cells that were allocated to the expanded array, even though they look empty. A good advice would be to go in the settings of DataLink and check the display not available instead of blanks. This way, you would easily see if your cells are part of an array or not. The next function we will use is the time data function. Since this function returns values for specified timestamp, it is really useful when you want to compare two attributes that does not have exactly the same archive values. Using it is fairly simple. Select the timestamp function and link the appropriate cells to the right parameters. The root path, well, will be the root path. The data item, in this case, would be the attribute SOX. And the timestamp would simply be the complete column of timestamp we already have. Once this is done, simply double check the output cell and press OK to get all the values. Now we can simply add the units of measure using the properties function, just like that. So route path with route path, data item with the attribute name, and then select unit of measure into the properties. And there it goes. You've got your complete dynamic report on NOx and SOx emissions.